Here we have the integral dx over the square root of 4 minus x squared. Now to clean this up easily, what we'll do is we'll first rewrite it as the integral of 1 over the square root of 4 minus x squared dx. And now we have an a squared minus x squared pattern here that has emerged. And so what we can do is recognize that we have a subtraction, which will pair nicely with either a secant or a sine. And because we have a first rather than x, it will be a sine. So we can say x equals a sine theta. And because this is a squared, and that is 4, a is simply 2. So we'll say x equals 2 sine theta. In this case, the derivative of x is simply 2 cosine theta d theta. And now we can go ahead and plug these values into our integral. So if we rewrite this, we can say the integral of 2 cosine theta over the square root of 4 minus 4 sine squared theta d theta. And now we perform a constant purge where we move the constants out front. And so what we'll have is 2 over, of course, we have the square root of 4 here that we can pull out, and that will be the square root of 4 here, which is 2, times the integral of cosine theta over the square root of 1 minus sine squared theta d theta. Now, of course, thank you to our Pythagorean identities, we know that 1 minus sine squared theta equals cosine theta squared theta. And so we can replace this with cosine squared theta. And it's under a square root symbol, therefore we know that it simplifies even further just down to cosine theta. So rewriting this, we can cancel these 2's. We'll have the integral of cosine theta over cosine theta d theta. And of course here, this just simplifies to 1. So what we're really working with is the integral of 1 d theta. Integrating 1 with respect to theta gives us theta. And because we're working with an indefinite integral here, we must add a constant. But we're not finished yet. We have a result in terms of theta, and we started this problem in terms of x. And so what we can do is go to where we transformed x into theta here. We said x equals 2 sine theta, and we can rewrite that down here. X equals 2 sine theta. And we can solve now for theta. And so what we have is we can rewrite this as sine theta equals x over 2. Solving now for theta, we can say theta equals sine inverse or arc sine of x over 2. And now we can go ahead and plug that in here. And we can say arc sine x over 2 plus c. And this is the result of our integral. If you have any questions, leave them in the comments below. Otherwise, I hope that you found this helpful.